Hello and welcome to this video where we'll go into Postgres Sync. Not only Postgres Sync, but we will actually go into getting data from an API, from a REST API, and we will loop it so that we will get the data in a certain frequency. So this is actually called polling data. So we're doing polling and this will give us streaming, but then we will poll it with a certain frequency. We will ingest the data from an API using a producer to publish events into our Kafka topics. And then the Kafka topics, we will also make sure that it is persistent, so that we'll make a bound, which we haven't done before. And then when it has been persisted into the topics, it means that whenever we're closing it down with Docker Compose down, and then we're opening it up again, Docker Compose up, then the events are still in the topics. And after that, we will consume this data, consuming using a consumer script. And for the Kafka, we will use quick streams as we have done before, which is very easy, very good client for working with Kafka. And then, so we have now consumed the data, we will do a sync. So that means we will store it into somewhere, and this somewhere is the Postgres, a Postgres SQL, which will spin up in, it's another container. We have a multi-app container here. We have 4 containers actually. So we have broker, we have Postgres SQL, we also have control center, and we have the schema registry. So with this, I would like to go directly to Visual Studio Code to spin up our containers, starting with that. So see you in Visual Studio Code. So now I'm in Visual Studio Code. So let's do like this. I will do terminal, new terminal, and here, Postgres Sync. Yes. So let's start with creating a virtual environment because I will use that. So then .ven activate. And then we will install some packages. So install, what do I need? I need IPy kernel, because I want to go into Jupyter Notebook to do some EDA on the actual API. And then we'll need pandas to work with pandas, and we'll need the quick streams and Postgres like this. Let's see, I think it's like that actually. So what do we have? Pip install IPy kernel, pandas, quick stream, Postgres. Do we need something? We need requests to get the data. So starting with this one, these few things, and we also need to have .python.env like that. Okay, cool. So that with this, I'm finished with the installation. I think there might be some other things. However, let's do docker ps now to see we don't have anything. So docker ps-a, we don't have anything. So let's create the patch. So let's say docker compose.yaml. And then I will open this one, Docker Compose YAML, and basically I'll just copy it from my lecture notes. So here we have the broker, and the new thing here is that I think we haven't gone through it before, but basically I have volumes here called ./Kafka data, and then I have /temp/graph-combined logs. So this is the bind mount where I will bind mount where we have the logs from our so that we can actually get storing the offsets so that we store the data basically. So it will create a folder here called Kafka data. So when it creates a folder called Kafka data, this will generate a lot of files for Git to track if you're working with GitHub repository. Let's do touch.gitignore. And probably you already have a gitignore if you're working with GitHub repository or Git repositories, but we have gitignore, and I will make sure I'll add this one, k_data, so that this folder here that is created, that one will be ignored, okay? Then we have schema registry, and we have control center, and then we have Postgres. And in the Postgres, it's the same as in the last time. So we have a lot of environment files, right? And talking about the environment files, we need that as well. So code.env, and I'll save this one. And in here, you need to type in your environment variables. So I will type in this and also this one. And then we have the password as well. So your super safe password. And also we will also in our environment put in our API key for working with the API, as I said, but coming to that later on. Let's start with this one. And remember to change this Postgres password to your own. So actually I will work with Coinmarket API. So this is for getting cryptocurrency data. Let's go into the browser here. So if you go into this Coinmarketcap, create an account and so when you have created an account and you have logged in, you can, for the free account, the basic plan, there are some APIs which you are allowed to use and some that you're not allowed to use. For me, you can see that we have 10,000 credits, 10,000 calls per month. And this is how many credits I've used this month. And these are basically just for testing out. And here you can see my API key. Actually, it's not for you to see. So you should create your own and copy that one. Okay, moving back to Visual Studio Code. Then you have CoinMarket API, and then you copy in your API key. So I will pause the video and I will do that. Great. So now I have copied in my API key, and now let's spin up our container. So Docker compose up -d. Let's see. Yeah, it needs to pull some images. Yeah, Postgres pull all other images I've already have. So this goes very quickly for you. It may take some time for you to download the images. So if I do Docker PS, you can see here we have 4 containers. Actually, I will do this so that you can see all of them. So here are them. They are control center, schema registry, Postgres, and broker. So let's make the SRC for source and make the explorations. And then I will do patch EDA, let's see, coins EDA.ipnb. Let's see, it should be in SRC. So I create, or not in XRC, actually I wanted it in explorations. Then move it to explorations. So this coins EDA, I want to do some explorations of the API before we actually build our pipeline. So we should understand how this API works first. So going into the browser now, let's see if I go here, we can see Coin API documentation. Perfect. And when going into, let's see, cryptocurrency, yes, here you can see some interesting things. Here are some endpoints. Actually, we will use latest. Actually, there's also V2, but I have used V1. So let's do V1. You can see here you can see the endpoint is available on the following API plans. And we actually have basic if you're not paying for it. So it says the update frequency and plan credits. Here are the parameters that you can read about, query pair parameters. And here you have some API documentation. Let me zoom out a little bit. And basically it looks like this. You have latest and you have data, and here are the IDs. So you can get the name. The first one is Bitcoin, and then you can see going on to the second one is actually Ethereum. They only had 2 in this case. But it should be able to filter on which cryptocurrency you want. So I'll show you how to do that later on in this lecture. If I search on Python, yeah, exactly here. I just searched for it, and you can see here are some languages. As we're working with Python, we go in here, and this is the code that you want. So I'll just copy this one. And then I will go into Visual Studio Code. Currency. Let's see, cryptocurrency, coin market, EDA. Let's see, and the kernel, we choose our virtual environment. I paste this one in, and this should be in Python. Okay, so you can see the URL here, and here is an API key, and this is a fake API key. So if I just run this one, you can see there's a lot of data. but these are fake data based on this fake API key. Okay, so how do I get the real API key? I do that through my .env. So from .env import load.env, and then I will do load.env, and I will also do import OS. And OS, let's see, then we'll go into the headers. You can see that this is the API key, right? So we'll just replace this one with what we have. os.getEnv, and what is my API key called? I called it Coinmarket API, or Coinmarket API key, or Coinmarket API. I forgot, but let's try this out. Circulating, yeah, it's still not working. Could it be API key? Status API key missing. Okay. API. Let me just to make sure what I got. Yeah, I call it Coinmarket API. Does this work? We have status, we have slug. It's weird. It's not the same. Let me restart this one. So I have my .env here. Let me run it again. Okay, let me pause the video and come back. Okay, I've got it. It's the URL that needs to be changed. That is the sandbox API URL. So just remove this one. And actually for the quotes, you need to change a little bit of the parameters. You cannot have this instead. We have symbol, and what symbol we have? For example, the target symbol. And the target symbol is basically just a variable which you can set when you're putting this into a function later on, which is very good to do in case you want to reuse this one, of course. So, for example, BTC, so that we can get Bitcoin. This is the symbol of coin. Let's see, we need to put in the currency. What currency do we want? We want to convert it into USD, and it takes the API keys, get in like this. Actually, we can clear it up a little bit. We can do like this API key. And then we can place an API key here. So headers and parameters needs to be placed into this. So session is used for opening up a session to get the connection, and using the session, we can get the response. So we put in the URL, we put in the parameters, and we have here, we update the headers with headers. So I update it with these, and then we get back the data basically. So if I run this one, I should get data. Yes, I get. So I see symbol BTC, and then there's a lot of other things that is quite hard to understand, but we shouldn't print it out like that. We can actually do that like this so that we can get it out a little bit nicer. And I will also do the data.keys. Okay, so you have data, you have got the keys, it's BTC here, and then you can continue going into the BTC and you see all the keys here. And also you can go into checking out like here's the name of the BTC, and then you get Bitcoin and BTC data. Let's continue to write BTC. Let's see what we have here. Bitcoin, okay. Let's see, continue, date added. Let's see what that is. Okay, 2010. Yeah, that kind of makes sense. TC data of, let's see, quote is interesting, but that actually quote I would put in the next one. Let's see, like this. Okay, I will go into BTC data and I will go into quotes. Here, this is the latest price that we've got, and yeah, and we can see here the latest price is this much, insanely much, and then we have, okay, you can see the percentage change in 24 hours, how many percent change. Okay, it's actually quite volatile. It says minus 13%. That's amazing. And then we have percent change 1 hour is this much, percent change 24 hours, or actually this was volume change, not percent change. Sorry, I couldn't read. Percent change minus 3.36%, that is also quite much, etc. But I don't know the cryptocurrency market, but it seems to go up and down a lot. Okay. So we have a BTC data quote. So now you can see that, okay, if you're inside of the quote, you can go into USD and you can start to get the latest prices. So here you have the quote, and inside the quote, you can go into USD, and you can see if you go into price here, you can get the latest price. Cool. And also there's something else that is really cool to do. You can actually start to explore other things. For example, you can go into finding all the listings, and there's a lot of cryptocurrencies. Actually, you can get 5,000 of them. I'm not sure. And also there is some cryptocurrency, some other endpoints that is worth to investigate and explore. But I will leave it to you so that I won't take out all the fun. I'll just do BTC and interesting. So clear the terminal. Let's create our pipeline now. This is the interesting part, according to me. So we create coin consumer.py. We create coin producer.py. So we need to publish events from the API. And when we publish it, we want to store it in Kafka, right? And then we want to consume it from Kafka topics, and we want to sync it into Postgres. That is the goal of this lecture. And also I will create something called constants, which I usually use when I have several constants that I want to reuse. So basically it's OS is .env, and then a load.env, and then here we get the Coinmarket API, we get all this for the connection into Postgres, right? Because I will reuse this in several places, it's good to separate into constants. So this gives me the freedom to just import it. So also to not make the other modules bloat. So not make spaghetti code, not make them too large. Instead, divide into smaller modules and import stuffs. That is what I want to do. Okay, so going into the producer, let's create this one first. This one is quite simple. So import time, we need to use time in order to do sleep frequency. And then I'll do from quick streams, import application, of course, that one we need. And then from constants, what do I need from constants? I want to import Coinmarket API, and then from requests, import session. So I just copied it from the documentation. Import JSON, we need this one also, load it, and then we can do like this. App equals to application, and then broker address. What do we have? We still have the same as before, 1992. And then we have consumer group. What is our consumer group? It's a coin group. You just give it a name, and then you use the same one when you're consuming it. So it's called coin groups for us. And then we create the topics. Coins topic equals the app of topic. It's called coins. And then we have the data in JSON, right? So we need to serialize it, serialize JSON data. Then I will create a function. I'll create like this. I'll go into my coins EDA, and I will steal this code here, basically. API key, that one will import. So I'll take this part. Yeah. This part I'll copy. And then I will do def get latest coin data, symbol equals to BTC. And then I will paste this code in. Okay. So you can see target symbol is basically symbol, API key. Let's see. We go into constants, Coinmarket API. So Coinmarket, and let's see, API key. We can do like this. API key. Actually, I will place it inside here. So Coinmarket API goes into here. We have Coinmarket latest parameters. We get the data, right? And here we can basically just return this one if it's successful. Otherwise, we have an error exception. Then we need timeout and too many redirects. Request too many redirects, and we have a timeout like this. Yeah, basically like that. So if the Python preamble, if dunder name equals to dunder main, let's do get latest coin data. And then we get the JSON, right? So result equals to that one, and I will do pretty print of my result, and I need to import pretty print. So from pprint import pprint. Okay, like this, and then I will run this one. And you can see we get the data. Perfect. Okay, then we need to go a little bit deeper here. Let's see, we have JSON.loads of this one, then basically just pick out the data, .get data, and if I run this one again, we can see we actually get into BTC, and then we can do .get of the symbol, right? The symbol that we put in is BTC. If I run this one again, then we should go down into actually like this. Perfect. Now we're inside of Bitcoin because you can see that the name is Bitcoin. However, if I change this one to, for example, ETH, and I run this one, you can see now we're into Ethereum, right? So I have now done a request, get request, and it works. We got the data back. So let's now do the interesting part. So now it's time for us to actually do some looping. So def main, and I will do like this with app dot get producer as producer, and you have seen this one before. And here now, while true, I want to run this forever, ever and ever. Okay, and what do I want to do? I want to do this coin latest equals to get latest coin data, BTC, and then we will create our Kafka message. Kafka message is goes coins dot serialize, and what I want to serialize, the key is equals to coin latest of symbol. So now I create a symbol, and I use BTC then as the key here. And then the value is equals to coin latest. So basically I just pick everything and serialize it into binary and place it into my Kafka topic. And the key is symbol, right? So the key is BTC in this case. And now I will just do a print here. Produce event with key equals to Kafka message, and the value equals to, and then I will just pick, for example, the value, not the whole value actually, that is quite hard to, I will call with price, let's do like this, coin latest USD, and then we go into the conversion, and we go into the price like this. Okay, but we haven't converted yet, remember? We haven't actually produced yet. So we do producer.produce topic equals to coins topic.name. So coins topic.name, we have the coins, we place it into this topic. And then we have a key equals Kafka message.key, value equals to Kafka message.value. So basically we produce this one, and let's do time.sleep 10 seconds. We let it produce a few. Okay, then we just comment this out and run the main function. And if I'm running this one, you can see that something is happening. Okay, it's produced event, and we can see quick streams to model Kafka message. Okay, not really correct. Let's see, Kafka message. Yeah, this is not really correct actually. Control C. Let me see why. We get the symbol. We get, let me see, we get the symbol here, and we get the symbol. Oh, because print is not printed the key, sorry. Now I print the key. Yeah, now key equals BTC and price equals this much. And then in 10 seconds, we get the next value. Yeah, exactly. You can see the next value and it's the same because no one has bought yet, or it hasn't updated. Probably it hasn't updated. But you can see after a while that it has changed. Yeah, now it changed. Cool. You can see that someone has bought or sold, or both actually. Yeah, I'm not good at investment. Okay. So now we have created our producer. So let's consume this one. So go into consumer. I'll let it run for a while we're writing out the consumer. So inside of the consumer, let's do like this. From quick streams, import application from quickstreams.things.community.postgresql import postgres SQL sync from constant import. What do I need here? I need to have PostgresDB name, Postgres host, Postgres password, Postgres port, Postgres user. Like this. And now let's do like that. For creating a sync, we need to do, or actually we can create a main first. Main. And in the main, we create our application. So app equals to application. Broker address equals to localhost as before. 1992, comma, consumer group equals to coin group. And then we need to auto offset reset equals to earliest. Okay, and that means we'll pick all the data. Okay, so coins topic equals app. So now it's time to create our streaming data frame. So SDF equals app dot data frame of our pick equals to coins topic, right? So now we have streaming data frame. So what to do now? This is interesting part. So SDF equals SDF dot apply. We need to apply a function. And I will call this function extract coin data. And then we'll create this function. Def extract coin data. Basically, what we need to put in is a message. I will do pass for now. Actually, I will do Control-C here, or I will comment this one so that I will use it soon. But I will do update lambda message print message, because we want to print it out in order to pick out stuffs, right? So that we can know what to pick out. So I will leave this producer on. It will be here. I don't care. I will let it collect some data. So if done the name equals done the main. Let's see, I'll run main. So then this will print out the message. So I run this one. Let's see what it says. Tycop G2 is missing. Run pip install quickstream postgres. Yeah, I think I did that. Let's do that again. UV pip install quickstreams postgresql. Like this. I need to have quotes here. Okay, now. So now I install this one. Let's run it again. Yes, it worked. Yeah, we haven't ran the app yet. Yeah, exactly. We need to do like this. App.run. Okay, perfect. Now you can see this is the data that we've got back. And there's a lot of data here that was printed, right? So we need to go into, in order for me to get some valuable data, what do I want to have data? I want to have the coin. Let's see if, let's do p print instead. from pprint import pprint. Control C. I'll run this one again. Oh yeah, now it has to wait for new messages to come. Okay, because it already have processed. So latest quote equals to message of quote. And in the quote we have USD, right? So quote USD, and we can get the latest quote, and we will return now a dictionary of the coin. Is basically, what is the coin? It's the message of name. So now we get the Bitcoin, right? This is the coin. Price USD. This one is the latest quote of price. And then we have volume. This is the latest quote of volume, 24 hour. Yeah, volume, we can have volume 24 actually. We can have updated. When is this updated? That is also interesting. So message of last updated. So you can find it here, all of them. Yeah. Okay, so these are some coin data, and of course there's a lot more. So to do for you is extract more relevant data. If I close this down and I do STF, I will do this extract data, and I will actually move this printing message down here. Print message, print. Yeah, this is the message after we have cleaned it. So transform data. So if let me see if this one's still running. Yes, I need to do like this. Python, src, coin consumer, like this. Okay, now you can see it's much more beautiful and it's cleaner, because this is the data that I've picked out. So I've done this apply function to my SDF and I picked this data out. But we're not done yet. We want to place this into Postgres. That is our main goal. The only thing we need to do is this. It's so simple. It's ridiculous. So we have here, after we have done our apply, we do like this. SDF, or we have Postgres SDF.sync, and we placed in our sync, Postgres sync. And what is our Postgres sync? Postgres sync equals to grade Postgres sync, and we need to implement this function. That is it. Create Postgres sync, and this is quite simple. I'll copy it because it's just, you don't need to watch me type it out. So you have Postgres SQL sync, and then you have the host, the port, the DB name, the user, the password, what the table name should be, and the schema update. Actually, you don't need this one, I think. So these are all you need. That is it. So now the data will flow into Postgres. So let's try this one. Close this one down. So I do sdf.sync Postgres. Python src coin consumer.py. Okay. I will let it run a little bit. I'll go into another terminal. Docker exec-id Postgres. Let's say Postgres and then bash. I'm inside of my Postgres container. PSQL -u Postgres -d coins-db. I'm inside of coins-db. \dt. I see Bitcoin table. Select star from Bitcoin. Ta-da! It's there. 4 rows. We wait a little while. Running. Yeah, we ingest data in a frequency of 10 seconds. So just wait a little while and we'll get more data. And as for now, it hasn't changed, but that will be interesting to see if it changes. Select star again. Now you can see it has changed. Oh, cool. And now we have it in Postgres. And yes, actually, we want to try one more thing. I will close this down, Control D, and I'll do Docker compose. Yeah, I can close this one down, producer and consumer, Docker compose down. So I close down all my containers. Docker compose up -d. I start them up again. And if I'll run the consumer, yes, it doesn't consume anything because it's waiting for messages. I'll run the producer. It produces. And I will do Postgres. And here PSQL-U Postgres-D. Let's see, what did I call it? Coins EB /DT. It's here. Select are from Bitcoin. Got in. You see it continues from where we were before. And that is super cool. So the data has persisted. And also the Kafka has persisted. We can show that as well. Create a new terminal. Let's see, broker. So Docker xf-it broker bash. Okay, inside here we do, let's see, Kafka-consumer-consumer-bootstrap server localhost 1992 -- points -- from -beginning. And you should have more than 13 messages. So we cannot see how many messages we've got, right? But if I do Control B now, or Control C actually, processed 74 messages. So it has processed all those messages. And actually some messages I've had before as well. Let me see. Coinbase. Yeah, it's hard to see actually, but yeah, Bitcoin here. Date added. Yeah, so I've run this before, so it has some previous messages. But no matter, you can see that the data has persisted. And that is a really cool thing because we have done a bind mount for the Kafka data. We have done name volume for Postgres. So you can see the data is persisted. Okay, so you have now watched the whole pipeline from getting the data from the API, producing the data into and publishing it into a topic, consuming, reading the data from the topic, syncing it into Postgres, and then read it out. So this is a pipeline for streaming data. How cool is that? Okay, with this, I would like to thank you for watching this video and see you in the next one. Bye.